Hello guys and welcome to Tech Talk, your tech survey program, and here we are at Tynwald High School, the school champion in robotics. So guys, let's get to talk to the headmaster, and then later on we are going to the science lab so we can get a better view of the robotics and everything they have here. But for now, let's get into history and trivia.
Robotics is a fascinating field that combines engineering, science, and technology to design, build, and operate machines with a blend of conceptual ideas and practical inventions, paving the way for the robots we know today. Key milestones in the history of robotics include some of the earliest automatons, like clockwork. The rise of industrial manufacturing led to the development of more practical automatic machines, like programmable looms and steam-powered engines. These early industrial machines laid the groundwork for modern robots. In 1920, the word robot was coined by Czech playwright Karel Čapek in his play I Your, Rossum's Universal Robots, depicting artificial beings created to serve humans. This play sparked a surge of science fiction exploring the potential and dangers of robots. The 1950s saw the first industrial robots were developed, with George Deville's Unimate considered a pioneering example. These early robots were large, fixed-arm manipulators used for repetitive tasks in factories. The field of robotics has seen continuous advancements, with the development of smaller, more versatile robots with sensors and computer vision, and artificial intelligence being the new norm.
This has been the history segment on Tech Talk. Join us after this break. So guys, as we said before, we're going to talk to the headmaster. So let's get to the office and meet with the headmaster and get a little chit chat, maybe a cup of tea perhaps. We are here with Mr. Matimba, the head of Tynwald High School, and we are going to get explanation and some answers that we want to know. So let's get down to business. Thank you so much for having us at your school, Mr. Matimba.
Thank you very much.
So, Mr. Matimba, we want you to tell us what is the story behind your school becoming popular in terms of the world of technology.
Right, thank you very much. What happened is when we introduced computer sciences at O level and A level, we had a teacher coming in to take computer science. Then the teacher is Mr. Matanga. We said, yes, we are offering computer science, but any other school is offering computer science. How can we distinguish ourselves? What can we do to make our school stand out in terms of information and communication technology? Also, we also realized that we had to keep abreast of developments in information and communication technology worldwide. With issues to do with artificial intelligence coming in, we then felt that we need to come up with a program, not that it was initiated at Tynwald High School, but it was a program that was being done in other countries, not necessarily in Zimbabwe. We then had to embrace it to say, let us introduce robotics. Why? We realized that there are some real-life problems that we had to perhaps come up with prototypes, and our prototypes, when further developed, they would then provide solutions to the problems that are bedeviling not only Zimbabwe, but that are also bedeviling Africa and the globe at large. As we speak right now, we are in an El Nino-induced drought. It is our hope that as a country, we should come up with a program to either aid and complement rain-fed rainfall. But what schools can only do is they come up with the prototypes. The onus is then on industrialists. The onus is also on even different ministries to further develop those programs into something which would then provide real goods and services.
We also want to understand what sort of investment goes into a venture like this in terms of the students, teachers, and the creations that create the whole robotics.
I would want to say a bit costly. Reason why, you also need to come up with what are called robotics kits. Mainly the robotic kits are imported. And let me take this opportunity to thank other partners who partnered with the school as we started, such as Potras. They came in and they helped us when we have the first robotics competition that we participated in. And during the participation, we actually got some of the kits for free. May I also take this opportunity even to thank the computer center at the University of Zimbabwe. We worked with them. They were also very helpful. But what is costly as far as robotics concerned are the kits. But as far as the software is concerned, definitely if you are offering computer sciences, you are doing programming, the students know the different programming language. It is the programming language that they use to command instructions into the prototypes so that they can perform different functions.
We also want to understand what sort of criteria do you use to do your selection for students who participate in robotics?
We believe as a school, our role is to identify people's wiring. By wiring, I mean, if a child is interested in sciences, what we do that is we then nurture that. So normally at this school, what we do is at Form 1, every child does ICT, Form 2 does ICT, and I understand that we no longer have ICT, but we now have computer science. So it's a question of any child who is interested in doing robotics, be it a girl child or a boy child, at any level, they can do robotics without any hindrances.
We understand that your school won an international awards in robotics competition, and it was honored by the president of Zimbabwe, Dr. Emerson Dambudzo Mnangagwa. Would you kindly tell us how that impacted or affected or gave embrace into your school?
It's not an everyday thing to receive recognition from the highest office in the land. Firstly, we felt very much humbled to say, who are we honestly to be recognized by the first person in the country? It acted as a stimulus or as a motivation subsequent to that which was recognized by His Excellency. We then participated last year in another competition which we participated together with a sister school in Manicaland called Milestone College, where we also won a first prize. And we are saying, I would want to believe that the handshake that we received from the first person in the land stimulated us to do further, not only to raise the school flag high, but also to raise the national flag high. But we are saying, besides being humbled, we were motivated by the recognition from His Excellency.
We want to understand, in your own point of view, how does robotic will affect, or how does it affect our day-to-day life?
Thank you very much. I would want us to start from the national vision. We are running with the vision 2030 towards a middle-income economy by 2030. But to anchor that at school level, we now have what is called the heritage-based education. And at tertiary level, we have reconfigured our tertiary level from Education 5.3 to Education 5.0. Education 5.3, we had teaching, research, and community service. But with Education 5.0, we now added two more pillars, which are industrialization and innovation. And we are saying, if innovation can start at school level, the issue is not just to come up with the prototypes. We then have to further develop the prototypes to come up with the real goods and services. And it is our hope that, yes, we may not replace human beings in certain aspects, but I would like a situation just like we watch in other countries, where you can be served with a robot when you get into a restaurant, where there are now robot cars, where we can have robots even gets into a landmine infested war zone affected area and do the demining, where we can also have even robots. Our economy is agro-based, coming up with the solutions. If it means maximizing land, having robots to do the harvesting, to do the planting, I would like that to complement human beings, because where we are limited as human beings, robots can do further.
Still on that note of Vision 2030, we want to understand, how do you believe that we can impact more on robotics in Zimbabwe?
I am happy. We received a high delegation which was led by the current Minister of Information and Career Services, Honorable Tenda Mavetera. And we are saying at national level, it's our hope that we should start. If it is at cell level, but at school, we now talk of, let's start at cluster level. Can we have robotics competitions at cluster level? Let's further develop robotics to district level, to provincial, to national level. And we are saying, just like someone said, Harare is not Zimbabwe, Zimbabwe is not Harare. Tynwald is not Zimbabwe, Zimbabwe is not Tynwald. What do I mean? I hope we should have robotics being done even in the remotest parts of the country. I hail from Bwera myself. I would want robotics to be introduced in Bwera. I would want robotics to be introduced in Checheche. I would want robotics to be introduced in Dande, in Bobi. And we are saying Rome was not built in a day. If we can have robotics being introduced incrementally in phased basis, and I am happy whenever His Excellency visits places, he is donating computers, he is donating ICT gadgets. And with that, we have a start. And what then is now left is the computers would then be used for the software part. Let's now have perhaps some kits being given. If it means 5 schools are given a set of kits, perhaps once a week, students go to a cluster. There are kids, they are taught how to assemble the robots. They are taught how to command the robots to carry certain functions. Let it be. But we are saying robotics should not only be confined to few schools. Let it cascade to even the remotest parts of the country.
Thank you very much, Mr. Matimba, for having us here. And we want to say thank you so much, guys. Now we move on to the next, and we'll be talking to the guys behind the whole tech stuff, the guys who touch and connect everything. Let's go and get that view in the Robotic Science Lab. So right now we are in the science lab, and behind us is students and the equipment that they use to make their robots. And also their coach, Mr. Matanga, is right there to assist in the explanation. So we're going to get a brief demonstration on how they put up the whole setup of these whole instruments, but I don't understand. Anyways, guys, let's give them a time to do what they do and show us how they work everything out.
Here with us we have the control hub, and we've got the battery and the motors. So basically we're going to be explaining how this ends up becoming that. So when we have the control hub, we all know that when we have a system, it needs the brains. So when it comes to the brains of our robots, most of them, they are controlled by the control hub. The control hub will connect the input devices, the output devices, such as motors, and input devices such as sensors, including most of the physical parts of the of the prototype, so that it can actually work together. So basically, as you can see, Tanatska has has generated power using the battery into the control hub, and here we've got the blue dots which are blinking. So basically what happens is that when the dot becomes green, it shows that the control hub now has power and can now control the whole robot, and which will help the driver control the robot. And what happens is that, for example, here we've got the cable which is going to be connected to the motor. What then happens is that when it's connected to the motor, we have various, for example, when someone gives the robot an instruction. They give the instruction via the input devices, and they are processed in the control lab. And when they are processed, the control lab would then send signals to the motors, and the motors would then allow the robot to move. They basically allow the wheels to move backwards and forwards, which will result in the robot moving and performing the designed task.
To add on what Zoe said, for the connection of the control hub to the programming device, the control hub releases a Wi-Fi signal that is connected to the programming device. So after connecting the programming device to the control hub, a user can now give the control hub instructions on what to do. For example, after connecting, this one will be the input device for the robot. So the programmer will instruct the control hub to receive signals from the input device. So after receiving instructions from the input device, the input device will instruct the control hub to inform the motor on what to do. Yeah, then we are now moving to the hardware components of robotics. So to begin with, we have two types of motors. We have a coax motor, then also we have got an HD motor. So those two motors work for different reasons. The first motor is used for speed. This one produces more speed as compared to this one. But then this one we can now add different gears to make it powerful. So these are the two types of motors. So after having a brainstorming session, we now determine which type of motor we're going to use for this specific task. For example, if you want to make a robot that can go up, we need to use this motor since it produces more power as compared to speed. Then we also have an extrusion. So as Zoe said, this is the backbone of the hardware component, because these are the ones that we use to assemble the robot. They are the bones sort of to a human being. Then we also have, these are brackets. So for us to connect an extrusion to another extrusion or an extrusion to another component, we use brackets. For example, this is a bracket, a 90-degree bracket that is used to connect another extrusion, like this. Then we also have additional materials such as sprockets. So for a moving object, it needs motion to be in both ends. So a motor will be connected to this sprocket. For example, if we had to put a shaft here, then we put a sprocket, it means that the motion that's coming from the motor is transferred to the shaft. Then the shaft will give motion to the sprocket. And on top of the sprocket, there'll be a chain. So it means for another sprocket, it's also now moving rotationally. This one is the input device for the entire robot's configurations. Unless if you are choosing autonomous mode, which uses automated programming skills that makes the robot move automatically. But then this one is for the physical component of the moving of the robot. Yeah, I think I've briefly explained most of the components we use.
So Laura, explain to us how this whole component works.
Okay, so then to begin with, this was a prototype that was built for us to compete at Italy for the first take robotics competition. So the function of this robot, it was to push pixels, a maximum of 2 pixels using this colorless backdrop over here to a place called a backdrop so that we could be able to earn points. And then also this mechanism right here, it was to launch a drone, like a pepper drone, to harness the prototype and the function of launching robots, harnessing the issue of physics. So then, this right here, this hook, it was meant so that the robot could suspend on its own. However, since it's like a multitask robot, it could be used in construction, like skyscraper building. Like you could use materials that are durable, for example, aluminium, to be able to build skyscrapers that are too high, alleviating the problems of human danger, like injuries. And also, you could implement this drivetrain in harvesting. For example, this backdrop right here, it could be used to harvest your crops, and it could also be automated, meaning that the farmer could put cameras and sensors so that they could be able to get a signal back if there are any obstacles that are taking place. Okay. And also, this hook right here, since we are trying to harness the issue of computer science and physics, we could use this in construction. Nowadays, people are trying to, to be more developed, meaning that they are supposed to survey and check out their buildings from time to time. So we could actually put gamma ray emitters so that they could be able to check for internal cracks in tall buildings that are actually like over age.
Okay, true.
Yeah.
So in terms of size, will this robot be a small size or big size? Because I can tell that by the way you're explaining, there's a whole lot of work and a whole lot of big things happening on it.
Usually, it now depends on what you want to use it for. For example, in farming, you could actually moderate the size so that could be big. However, we want to actually have like opportunity cost. So it's now up to you increasing the size, but then using durable material that's light and cheap.
All right, so I have Jaro here. He's going to explain what this company we have here is and how it works. What is this, Jaro?
So what we have here is a concept robot. Basically, a concept is an unfinished idea that can be applied to the real world. Some of you may have heard of demining. Demining is basically the removal of landmines. As we may all know, Zimbabwe is a post-battleground land, meaning that there are going to be mines that were used back in the war that we're going to need to remove. Over 1,000 people die every year due to this, and we're going to build this so that we can reduce this death. If you see here, there are sensors on the robot. These are going to be able to use a technology that's going to be able to pull out the mines and detect their geological location. After we find the location, we're going to use state-of-the-art steel to make sure that we can safely remove the mines without having to determine them whether they're going to explode. If you look onto the robot, we're going to use the same technology that planes use to avoid electricity in order for safe removal to avoid any explosion. One may ask, after we take the mines, where are we going to put them? We're going to have a safe storage facility where they're going to be detonated safely, of course, to avoid any injuries. And then we're going to take the materials from the landmines and recycle them.
Okay, so we might need to have a little bit of demonstration of how it works and how do you remove the mines from the ground with this robot.
Yeah, I have my colleague Nigel here to help me.
All right.
So just a quick brief of the situation. In here, we're going to have this. This is our robot. It's going to sort of resemble the robot that we're going to be using. And then we're going to have a box over here. This is going to be the landmine. So as you may see, we've got our driver here ready to go, and he's going to show us just how it works. You see the speed? Very experienced, by the way. So as you may see here, he has picked up our landmine, and it's going to be transported to a storage facility. In this case, we're going to have it to be this location, where it to be safely dropped, as Nigel is about to do. So this area here is going to resemble a storage facility. Once the mine has been placed down, it's going to be exploded in a safe manner, and all the materials are going to be recycled. That metal, we can use it to make simple things such as cups, cutlery, everything you may need in your household.
Not true. So according to your expectations of your robot,
Yes.
how would it look like and how would one tend to use it? How will you control it? Will it be inside, outside? How will it be like?
Well, our idea mainly is for a remote-controlled machine. Basically, it's going to be quite the same scale because if you may know, landmines are not that big. They can have a diameter of about 30 centimeters at most, and they're really not that big. So we don't need to use a big robot because, again, robotics is all about sustainability, and we want to avoid wasting resources. So it's going to be just about this size, and once we have a robot like this, it's going to be used to pick the landmines and safely dispose them.
All right, thank you so much. That was it from my Call of Duty buddy, Darrow, explaining how the landmine machine works.
You know, control this is some ports. You can connect your motor.
Thank you so much, guys. That's it for Tech Talk from me, JTK, and my friends here. It's bye-bye. I want them to say bye-bye today. I'm too tired to do that. Guys.
Thank you. Tynwald Robotics.
Peace.